Alright, this is day 13, part 2 of the review. Let's make this video happen. We are working on systems of equations. These two equations we get to solve by any method we want. Alright, this first one is feeling like elimination to me. All of the variables have coefficients. So let's go ahead and multiply the top equation by 2, and I believe that will make the x's into opposites. So the top equation will become 4x plus 6y is equal to negative 14. The bottom equation, I'm just going to copy it down as is. X's cancel out. That's going to leave y equals negative 1. Bam! That's one of the values we needed. Now we can get the x by plugging this back in. Okay, so I will just use the first equation, 2x plus 3y is equal to negative 7. And if I just take this negative 1, plug it in, so I have 2x plus 3 times negative 1 is equal to negative 7. That's 2x minus 3. Add it. So that's 2x equals negative 4. Divide by 2. That gives me x equals negative 2. Ka-bam! So that gives me negative 2 comma negative 1 for the answer to problem number 1. Problem number 2. This one's all about substitution method. See how x is by itself? It would be silly not to do substitution. So that's going to give me 2 times parentheses plus 12y equals 10. Alright, I just put a parentheses for the x. And inside the parentheses, I'm going to put this 4y minus 25. So if I go ahead and do that distributive property, I'm going to get 8y minus 50 plus 12y is equal to 10. Combine these like terms, that's going to give me 20y minus 50 is equal to 10. Adding 50 to both sides is going to give me 20y is equal to 60. Dividing by 20 is going to give me y equals 3. So we still need x. Alright, so I'm just going to take this y all the way back around and plug it in right there. So that is going to give me x equals 4 times 3 minus 25. Well, that's x equals 12 minus 25. So that's x equals, what was that, 13. 25, yeah. Negative 13. Phew, that was close. Okay, so the final answer should be negative 13 comma 3. Alright, substitution. Oh my goodness. Number 3, we have to do this whole system of 3 equations nonsense. Alright, it takes a little bit of time, but it's not as bad as it looks at first. First we have to decide which variable we're going to get rid of. Now right away I think I want to get rid of the x's because see, I already have a pair of opposites, and I'm going to do elimination method for sure. So we're going to need opposites at some point. Now you need to do 2 pairs, so I'm going to make 1 pair out of these 2. I just really am randomly picking those. But I'm going to make another pair out of these two. You can pick any two pairs you want. The blue ones really didn't matter, but I purposefully picked these red ones so I would have these opposites. I get to do the 2x and the negative 2x. This keeps life a little bit simpler. So let's see what happens. But if I'm going to do the x's, I need to make sure I do the x's throughout this problem. So first, let's go ahead and do the blue ones. And I like to recopy to stay organized. So the blue equations are 2x minus 4y plus 3z is equal to 1, and 6x plus 2y plus 10z is equal to 19. Okay, I already decided I have to get rid of the x's, so let's stick with that plan. If I'm going to get rid of the x's, it would work if I multiply the top equation by negative 3. Alright, I'm seeing I have a 6. If I multiply negative 3 times 2, that'll be negative 6. So watch this. The top equation becomes negative 6x positive 12y, right, distributive property, minus 9z is equal to negative 3. The bottom equation stays unchanged. 6x plus 2y plus 10z equals 19. When I put these together, the x's cancel out. This is going to give me 14y plus 1z is equal to 16. Okay, so look, that's as far as I can go right now. So that gives me my first boxed equation. I'm going to use this later. For now, I'm going to switch to red and do the two red equations now. Alright, so I'm just going to recopy. So that's 2x minus 4y plus 3z is equal to 1. And the bottom equation is negative 2x plus 5y minus 2z is equal to 2. Again, I liked these from the beginning because the opposites. So I don't have to multiply by anything, they're already opposites. So that's going to give me 1y plus 1z is equal to 3. Alright, so that was really easy. And that gives me my second boxed equation. So now I need to take these two boxed equations and make a system out of them and solve them. So I could either do elimination again with them, or I could do substitution with them. It doesn't matter. I've been doing a lot of elimination, so I'm just going to stick to that just in case that's what you're used to. So as I put these two equations together, it will look like this. I feel like I should do it in another column maybe. So there's your blue equation. So 14y plus z is equal to 16. Copy that. Alright, here's the red equation. Y plus z is equal to 3. I just copied that over. So I need to solve these and to find y and z. So now I can just get rid of whichever one I want to. Okay, so fine, I'm solving this system. I think I will multiply the bottom equation by negative 1. I'm going to go ahead and make this into a negative z. So that means the top equation stays what it is. 14y plus z is equal to 16. But the bottom equation becomes negative y minus z is equal to negative 3. So if I put these together, that's going to give me 13y, z's gone, is equal to 13. How nice. So wait, this was all supposed to be purple. Oh well, I guess it wasn't purple. So then I will divide everything by 13, and that's going to give me y equals 1. Boom! I have my first value. Now I can just keep going and find z, still staying in this column over here. How will I find z? I will take this and plug it back into either one of these I want. Clearly I'm going to use the red one because that's so simple. Let me just recopy it. So we have y plus z equals 3. So yeah, if I take this 1 and plug it in, this becomes 1 plus z equals 3. Subtract. So those are gone. So that gives me z equals 2. 2. Alright, kabam. So now I have y and z. So now I just need x. Alright, so to get x, I need to plug in my y and my z back into any one of the original equations I want. It doesn't matter which one. I'm gonna use the top one. Okay, so I'm about to use the top equation, and I'm just gonna bring it down like right about here. So what I have here is 2x minus 4y plus 3z is equal to 1. Now if I take my y and I plug it in, and I take my z and I plug that in, this is going to become 2x minus 4 times 1 plus 3 times 2 equals 1. So that's 2x minus 4 plus 6 equals 1. Like terms, so that's 2x plus 2 equals 1. Subtract. Okay, so that's 2x equals negative 1. Divide. Alright, so that's x equals negative 1/2. Now it always makes me nervous when I get a fraction. So I am going to pause the tape and check my work. Alright, great news. Checked my answer and I was right. Okay, so we will record the final answer as an ordered triple in the form x comma y comma z. So negative 1/2 comma 1 comma 2. That would be the answer to this big old problem. Alrighty then, that was number 3. That's how you do a triple system. Alright, number 4 should be pretty straightforward. Good old finding the maximum and minimum values of an objective function for the feasible region. What? Okay. So we've got the this thing, the objective function, c equals 3x plus 4y, and we've just got these vertices, which we're going to plug in one at a time. So we're going to do negative 1, 0, plug that in. And of course that's going to give us negative 3. Then we're going to take the 1 comma 3, plug that in. Alright, so that's 12 plus 3, so that's 15. So now I'm around to the 3 comma 2. Alright, so it's 9 plus 8, so that is 17. And then we've got the 4 comma 0. Which is 12. Okay, so as you can see, we have a maximum value of 17, which comes from this point right here, and we have a minimum value of negative 3, which comes in right here. So let's write that down. So maximum value of 17 at 3, 2. Minimum value is -3 at -1, 0. Alright, minimum and maximum. Done and done. Let's move on to number 5. Let's see what's what. Okay, we got a couple word problems to do. Tickets for your school's play are $3 for students and $5 for non-students. On opening night, 937 tickets are sold, and stand by. Alright, I was hesitating because I wanted to make sure I wasn't accidentally using the actual problem off the test and giving everything away. And who knows, maybe this is off the test. You'll only know if you did your homework and stuff. Classwork. Guess it's classwork. Anyway, back to work. I digress. Yeah, we got the on opening night, 937 tickets were sold, and $3,943 was collected. How many tickets were sold to students and how many were sold to non-students? So right there, that tells us what the variables need to be. Maybe I'll go ahead and use S for students and N for non-students. How about that? So we'll let S be the number of student tickets. Do not just say S equals students. You have to be specific. Number of student tickets. And we'll let N be the number of non-student tickets. Okay, so now I need two equations. Well, there's one little equation sitting right here. 937 tickets. So I should be able to write a nice little amount equation, alright, which shows up very often in these word problems. Alright, because I've got some student tickets, some non-student tickets. Here they're telling me that there's a total of 937 tickets sold. So that gives me the simple equation S plus N must equal 937. Alright, I feel like switching to red. Then we got this money. I should highlight that somehow, shouldn't I? Let me go for pink. Okay, $3, $5, $3,943. Alright, I feel a money equation coming on, don't you? Money. Let's see. $3 for students. It's 3S. Plus $5 for non-students. 5N. Total amount of money is right here, 3,943. So we have our simple little amount equation, very common. Equally common, we have our money equation. Okay, make sure it all matches. Money, money, money. All that goes together. Alright, so then we could do substitution or elimination or whatever. Alright, I've been doing substitution like crazy. I've been doing elimination like crazy, so I think I'm going to go ahead and do some substitution now. Yeah, let's make substitution happen. So look, I'm just copying this equation over here so I have a little bit of room. We've got S plus N is equal to 937. So, for example, say if I subtract N from both sides, then what I have is S equals negative n plus 937. You could have put 937 minus n and that would have been fine. Either way, I need to take this stuff and substitute it in for s over here. Okay, so I'm going to take this and I'm going to go here with it. Okay, so the red equation is going to become this. 3, now instead of s, I'm going to put this negative n plus 937. Alright, and then the rest of it, plus 5n equals 3,943. Alright, so I'm doing substitution. I could have just as easily have done elimination. Anyway, with some distributive property, that's going to give me negative 3n plus, alright, gotta punch this in my calculator real quick, 3 times 937, that is 2,811 plus 5n equals 3,943. Alright, we've got some like terms here with these n's. So if I put those together, that's going to give me 2n plus 2,811 is equal to 3,943. Time to subtract. So that'll give me 2n equals, okay, that's 11,132. Time to divide by 2. So that's going to give me n equals 566. Alright, that is the number of non-student tickets. Alright, time to find the number of student tickets. Well, I could just take this, put it right there. If I do, this is going to become s equals negative 566 plus 937. That's 371. So 371 student tickets. Now if I just stop here, I'm losing 10 points on the test. When you have a word problem, you have to turn it all the way back into words. Okay, so in words we would have to say something like this. Let me use a text box because my handwriting gets sloppy. Let's see, how many tickets were sold? Okay. 566 tickets were sold to non-students. And 371 tickets were sold to students. Alright, so always make sure you follow through and write your final answer as a sentence whenever you do a word problem. If you don't, you will lose a lot of points. Okay, that is how you do that. Also, don't forget to define your variables. If you forget that part, you're going to lose points for that too. Alright, we got another word problem. Alright, slightly different type. Jody bought 5 blouses and 3 skirts for a total of $215. At the same time, Colleen bought 3 blouses and 2 skirts for a total of $135. What was the price of each blouse and each skirt? So let's start off defining our variables. I will use B for a blouse, and it says what was the price, so that's what the variable has to be. So B equals the price of a blouse. and I will use S, and that will be the price of a skirt. Okay, so this is a slightly different type of problem, but it's a very, very common problem. Do you see the way these are parallel? I mean, I don't mean parallel like parallel lines. I mean how the first sentence and the second sentence are almost repeating. Only the numbers are changing. 5 blouses, 3 skirts, $215. Okay? 3 blouses, 2 skirts, $135. Alright, see how it repeats? These should be your favorite kind because the equation almost writes itself. Okay, because the equation would work like this: 5 blouses, 3 skirts, $215. Okay, it's so easy. It's just all set up for you. And it makes sense because if B is the price of a blouse, multiply by 5, that'll be the amount of money spent on blouses. If S is the price of a shirt, then multiply that by 3 because she bought 3 skirts. Then that will be the amount of money spent on skirts. Altogether, that should be the total money. So it does make sense. Anyway, it's easy to write the equation. So the other equation: Colleen bought 3 blouses, 2 skirts for $135. So there we go. 3 blouses, 2 skirts, $135. Okay, gotta love these parallel equations. I mean, I don't know. I keep saying parallel. That could be ambiguous. Not that kind of parallel. Anyway, this would definitely be an elimination problem because of all the coefficients. Now, we're going to have to multiply both of these equations to make anything cancel out, since 3 does not go into 5 evenly and 2 does not go into 3 evenly. So I might as well just cancel the b's since they're in front. So what I need to do is multiply both of these. So I'm going for 15s on the b's. So I'm going to multiply the top equation by 3, get a 15. And I'm going to multiply the bottom equation by -5 to get that -15. So if I do that, these equations will become, top equation becomes 15b plus 9s equals, just be sure here, 215 times 3, 645. Okay, bottom equation becomes -15b minus 10s is equal to 675. Alright, as I combine like terms, the b's go away for now. This is going to leave me with -1s, or just -s. And this is going to make, let's see, plus 645. That's -30. Alright, now that means, if we divide both sides by -1 here real quick, that means that S is 30. So that means a skirt costs $30 in this case. So that's one of our answers. To get the other answer, we pick one of these equations and plug this in. Alright, it doesn't matter. I'm gonna pick the bottom one. Just the numbers are a little smaller. Okay, so picking the bottom equation, I've got 3b plus 2s is equal to 135. But if I take this and plug it in for s right here, that's going to give me 3b plus 2 times 30 is equal to 135. That's 3b plus 60 So that's 3b is equal to 75. Oh yeah, I subtracted 60 from both sides. So if I divide by 3 at this juncture, okay, that's going to give me b equals 25. Okay, alright, so that means in this case a blouse was $25. Alright, it must be shopping at like Dress Barn or something, Ross Dress for Less, because these are some good prices for blouses and skirts. Don't ask me why I know that. 2 daughters, a wife, that's why I know that. Anyway, you must go ahead and write a sentence. If you leave it like this, you will not get full credit. You'll lose a bunch of points. Skirts and blouses. A skirt costs $30 and a blouse costs $25. Alright, guess I didn't need that big of a box. So that's how you do that word problem. So we just did 2 word problems. We're pretty cool like that. You know what? I don't think this is part of the. I think that's supposed to be the end. Yeah, that's the end. Maybe that's on the test. You better go write it down. You weren't supposed to see that. That might have been on the test. You better go write it down and do it. Figure it out, but don't ask me about it because I'm not going to tell you. You're on your own. Alright, well really, that brings us to the end of this review. Remember, this was not the entire review. This was part 2. There's a bunch of stuff that's not on this sheet. For example, the rest of the linear programming stuff, with the linear programming word problems, and those graphing, solving systems by graphing, and with the shading and the dotted lines and solid lines. That stuff was not on this review, but you are responsible for it. Maybe it'll be on the homework. Alright, anyway, I will see you on the next video. Ta-ta for now.